So this is the most important slide, right, for chapter 3, really. So pay attention over here, because this is where students make a lot of mistakes. There are a few facts that you need to understand. First is, this I'm repeating it, mass is a base unit in a SI system. So kilogram is a base unit in a SI system, while force is a base unit in the USCS. Okay? So these are your starting points. USCS system has two different units for mass. One is a pound mass. One is a pound mass, and the other is slug. So there are two units for the mass in the USCS system. So then the question is, well, how do we relate slug with the pound mass? And which one should we really use in formulas, right? Those are the things that we want to know. There are two facts highlighted in red over here that you need to memorize and remember. You need to commit it to the memory. Number one fact is that 1 pound force acts on an object of mass 1 slug when it undergoes acceleration of 1 feet per second squared. Now, there is nothing new in here. You actually know most of this stuff. You know the definition of a Newton, right? What's the definition of a Newton? Definition of 1 Newton is that if you have a mass of 1 kilogram, which is accelerated at 1 meters per second squared, then the force produces 1 Newton, right? F equal to ma. M being 1 kilogram, acceleration being 1 meters per second squared, produces a force of 1 Newton. Same thing over here for the USCS, except that the force is no longer Newton, it's 1 pound force. The mass is not 1 kilogram, it's 1 slug. And the acceleration is not 1 meter per second squared, but 1 feet per second squared. Right? So all you're doing is taking that basic definition that comes from the SI system and writing your units in USCS system, where the mass is slug, acceleration is in feet per second squared, and the force is pound force. Right? So if you look at this fact, you can clearly see that 1 kilogram in SI system is equivalent to 1 slug in USCS system. Right? So the role played by a kilogram in SI is the role played by slug in USCS. That's it. That's all it is. So there is a clear parallel between the two, right? And everybody should remember this, right? Kilogram, slug behave similarly across the two unit systems. Number two fact is, and this is something you need to pay attention to, is that 1 pound mass of something weighs 1 pound force. And that's just a definition. So 1 pound mass of something weighs 1 pound force. Now notice, I didn't say 1 pound mass is equal to 1 pound force. That would be wrong, because you can't equate mass with the force. What it is saying is 1 pound mass of something weighs same as 1 pound force, right? Now, when you go to buy something in the grocery store, how do you buy? Let's say you want to buy 5 pounds of apple. What do you really say? I want to buy 5 pounds of apple? What is that 5 pound? Is that pound force? Is that pound mass? What is that 5 pound? Yes? It's a unit of force. 5 pound is unit of force. So when you simply say pound, you're essentially saying the weight of my apple should be 5 pound, right? But if you look at this fact, it's telling you that 1 pound mass weighs 1 pound force. So 5 pound, when you say, is also 5 pound mass. Right? So when you buy 5 pounds of apple, it doesn't matter whether you say I want to buy 5 pound mass of apple or whether I want to buy 5 pound force of apple, because 1 pound mass weighs 1 pound force. Right? Okay, so how do we translate all this into conversion formulas? So if you have heard about the conversion formulas to go from slug to pound mass and things like that, you will now see where they're coming from. Right? So first thing is, let's look at the SI system. In the SI system, using the force equal to mass times acceleration definition, if you have a mass of 1 kilogram, acceleration as 1 meter per second square, then what you get is 1 kilogram meters per second square, and kilogram meter per second square is defined as Newton. Right? So instead of saying kilograms meter per second square, once you multiply mass with acceleration, mass being in kilogram, acceleration being meter per second square, you get your force in Newton right away. If you have a 5 kilogram object accelerating at 2 meters per second square, you get 10 kilogram meters per second square, which is same as 10 Newton. And I'm pretty sure that none of you have any problems with this, right? Okay, good. Let's see what happens with the USCS system. Because in USCS system, the mass is a derived unit, right? Here we derived the force to be the unit. Okay, again, same definition. We already know that 1 slug mass accelerated at 1 feet per second square gives rise to a force of 1 pound force. So let's write that. F equal to ma, mass being in slug, acceleration feet per second square, we get mass times acceleration slug feet per second squared. And this whole thing is nothing but 1 pound force. So I can write this as pound force or pound, right? So pound force, same thing. So 1 pound force is equal to 1 slug feet per second squared, right? So this is coming from the first fact. Now let's use the second fact, which says 1 pound mass weighs 1 pound force. So we got that, 1 slug is equal to, this is just a reiteration of that. So all I'm saying is that, well, let's take the feet per second squared on the other side, and we can write slug equal to pound force times second squared over feet. So that's all it is. So it's just a rewriting of this, and where I'm writing the slug on all by itself on the left-hand side. So second fact, weight of 1 pound mass is 1 pound force. What is the weight of something? Weight of something is nothing but mass times gravitational acceleration, right? So 1 pound force is now equal to the mass being 1 pound mass times g, which is gravitational acceleration in feet per second squared, as 32.2 feet per second squared. So when you write this, we get 1 pound force equal to pound mass times 32.2 feet per second squared. And I know pound force times second squared over feet is nothing but slug. So I get this as my conversion formula, which says 1 slug is equal to 32.2 pound mass. 1 slug is equal to 32.2 pound mass. So if, let's say, you were given a problem, and you will see a lot of problems like these where you'll be given maybe the weight of an object in the USCS system as, I have a truck of 5,000 pounds, and I want it to accelerate at, I don't know, maybe 40 meters per second square. That's too much, but let's just make up some numbers. How much force is needed to make this truck accelerate at that acceleration? You can simply take 4,000 pound force multiplied with the acceleration given to you, because in the F equal to ma formula, the mass should be in slugs. Mass should be in slugs in that formula, which means that you need to convert your weight of the truck given to you into the slugs. So how would you get that? Well, we know that 1 pound mass weighs same as 1 pound force, so you need to divide by 32.2 to get everything in slugs. That's it. Once you have that, then you can plug it into the formula, right? So let's look at an example. So first of all, we want to buy 5 pounds of apple, right? That's an example. So what is 5 pound? 5 pound, the mass or force? Is force. 5 pound mass weighs 5 pound force. But over here, if you simply say 5 pound, technically speaking, it's a force, it's the weight. How much does it weigh? 5 pound or 5 pound force, right? What force is produced when it is accelerated by 2 feet per second squared? Now this 5 pound is really the weight, which means we need to convert into the slug. How do we do that? We divide by 32.2. Because in this formula, the mass should be in slugs, right? Just as if you were using the SI system, the mass should be in kilogram. Here, this should be in slugs. Multiply the two, and you get something like this, right? So we get that. Okay, that's good. Now, we also have derived units, right? What are the derived units? Derived units are the ones that come from the base units, okay? And there are quite a few of those. So this is just a sampling of them, right? It's not like that I can present all of them over here. So in the SI system, micron or micrometer is a derived unit of length. And what is that given as? As 10 power minus 6 meters. You know that. So this is a derived unit. Liter, which is 1,000 cc or 1,000 cubic centimeters. Cubic centimeter can be written into meters. So that's 1,000 times 10 power minus 6 meter cube. So that gives you 10 power minus 3 meter cube. So that's 1 liter is a derived unit in a SI system, right? Newton is a derived unit. Newton meter is a derived unit. Pascal is also a derived unit. It's 1 Newton per meter square. Joule is a derived unit. Watt is a derived unit. Degree Celsius is a derived unit, right? So he was asking about the Fahrenheit. Fahrenheit would be a derived unit in USCS system. Okay. Then you also have the prefixes, and I'm sure most of you have been using prefixes without maybe paying attention as to when you should be using the prefixes, right? So if you want to write, let's say, I don't know, tera, right? You have terabytes of hard drives these days. What is that tera? 10 power 12, giga is 10 power 9, mega is 10 power 6, kilo is 10 power 3, hecto is 10 power 2, and you've probably not seen hecto and deca that much, right? You have 10 power minus 1 as deci, centi, milli, micro, nano, pico, right? So the whole prefix that you have probably seen in other places as well.